Hi, I am Sushma, working as Assistant Professor in the Department of ECE in Institute of Aeronautical Engineering College. In this session, we are going to discuss about Boolean Algebra and the basic theorems and properties of Boolean Algebra. So, the contents today we are going to discuss are Boolean Algebra, basic theorem, properties, minimization of Boolean expression using Boolean Algebra. So, first, Boolean algebra was invented by George Boole in 1854. So, what is Boolean algebra? Boolean algebra is used to analyze and simplify the digital logic circuits. Okay, so whatever the digital design we are designing, that digital logic circuits will be analyzed and simplified by using Boolean algebra. Here the Boolean algebra mainly deals with logic 1 and logic 0. Logic 1 and logic 0. Logic 1 is for high state and 0 for low state. Okay, so here totally this Boolean algebra deals with two logic levels, logic 1 and logic 0. Boolean algebra is the basic mathematical needed for the study the logic design of digital system. So it may be defined with a set of elements, set of operations and number of unproved axioms or postulates. So here it has some rules and theorems for Boolean algebra and it contains set of elements and set of operators. Okay, place. And this is for OR operator and dot is for AND operator and complement, so X bar, so that complement. So we will use this set of operators in the Boolean algebra. The postulates, the rules of a mathematical system form the basic assumptions from which it is possible to deduce the rules, theorems and properties of the system. So these postulates of a mathematical systems are used to reduce the rules, theorems and properties of the system. Boolean algebra is an algebraic structure defined on a set of elements together with two binary operators plus and dot. So the plus indicates OR operation, dot indicates AND operation. So OR is nothing but if any one of the input is logic 1, then the output goes to high. Okay, for AND operation, if any one of the input is 0, then output is 0. If all the inputs are 1 only, the output will be 1 in the AND operation. So here AND is denoted by dot and OR symbol is denoted by plus. So these operator plus and dot operators are two binary operators in the Boolean algebra. So here the we are going to discuss the Huntington postulates here. So we have to know the laws and theorems of Boolean algebra to simplify the logic equation. Okay, so here the operations with 0 and 1. First we will discuss the operations with 0 and 1. So here the first one is x plus 0 is x, x plus 1 is 1. So how we are going to say what is x plus 0 is equal to x, x plus 1 is equal to 1. Suppose here in x plus 0 is equal, we are saying it is x. Suppose if x is equal 0, then we can write this as 0 plus 0, that is 0. So whatever x we are getting, here we are getting 0. X is 0, we are getting 0. If x is equal 1, then 1 plus 0 is 1. We know plus indicates here the binary operator OR. So if any one of the input is 1, so here we have 1 plus 0, then output will become 1. Okay, so that is here we are getting x is equal 1, we are getting x as output. Here x is 0, we are getting x as output. Okay, so here in this theorem, x plus 0 is x and x plus 1 is 1. So if for OR operation, if any one of the input is 1, then automatically the output is 1. For x plus 0, here whatever the x we are applying, if x is 0, that will goes to output. If x is 1, that will goes to output. So x plus 0 is 0, x and x plus 1 is 1. So these are the operations with 0 and 1. And duality. So what is duality means here? In duality, the logic operator and the logic value. So here mainly we have logic variables, so like x and y like that, are operators plus dot and operator, complement operator. Okay, logic values are 1 and 0. If we consider these three for duality, we will see the logical operators, binary operators, and logical values, logic 1 and logic 0. These values will be changed in the dual constant. That is nothing but, suppose here we have x plus 0 is equal to x. The duality of this equation is the operator variable will not change. The operator plus will become into, or operator will become and operator. Logic 0 will become logic 1. And here operator will not change. So x will become x only. Okay. So only the logical operator and the Boolean values, the logical values, binary operators and the logical values will change in the duality operator. Okay. Suppose if you want to write duality of x plus 1 is equal to 1. Okay. How we can write the duality of this equation? The variable will not change here. So plus will become, our binary operator will become and binary operator. 1 will become 0 is equal, 1 will become 0. Okay. So this is duality of the second equation. So how to prove this duality? X into 1 is equal to x. Suppose if x is equal 0, then 0 dot 1 is equal 0. Okay, so whatever x we are giving, that is coming to the output. If x is equal 1, 1 dot 1 is equal 1. Dot means binary operator and operator. Okay, and is nothing but if any one of the input is 0, output is 0. If both the inputs are 1, then the output is 1. Okay, so 1 dot 1 is equal 1. So here if you observe in the first case, so we are changing x as, if we are taking x is equal 0, same we are getting at the output, and if x is equal 1, same we are getting at the output. So x dot 1 is equal x and x dot 0 is equal 0. Automatically we can say apply this, because this is the AND operator. If any one of the input is 0, then automatically output goes to the low value, that is 0. So x dot 0 is equal 0, x dot 1 is equal x. Duality of the first and second equations. Okay. So idempotent laws here. So here this is also very important law. X plus x is equal x and x dot x is equal x. The duality of this one is x dot x is equal to x. So how we can write the duality? So here variable will not change, only the binary operator and logic values will become change. So x and plus will become and operator, x dot x is equal x. So the duality of this third equation is x dot x is equal x. So in duality, the or operator will become and operator will become or operator. Okay. Our logic 1 will become logic 0 will become logic 1. So here in duality operators, if we take 1 plus 1, so here plus means here it is the binary operator, that is OR operator. 1 plus 1, both are 1 means that is 1. Both are same. Suppose x is equal 0 plus 0 is equal 0. Whatever x we are taking, same x is coming in the output. So x dot x. So for if x is equal to 1, then 1 into 1, 1. X is equal 0, 0 dot 0 is equal 0. So whatever x value we are taking, that is coming to the output. So in idempotent law, here x plus x is equal to x and x dot x is equal to x. So involution law is x bar whole bar is equal to x. This indicate negation or not operation. Okay, so we can write this as x bar whole bar also we can write. Okay, this is equal to, we can write as x bar whole bar. So here, suppose x I am taking 0. So x negation will become, 0 will become 1. Again, we are applying the negation to the x bar. So 1 will become 0. So whatever x value we are getting, same value we are getting here. So x negation of whole negation is x. Okay, x bar whole bar is equal, we can call that as x. So laws of complementarity. So here x plus x bar is equal 1. This is also important. X plus x bar is equal 1. The duality, how we can write here? So variable will not change, only binary operator will change. So plus will become, or operator will become AND operator. Variable will not change, is equal 1, logic 1 will become 0. So this is the duality of fifth equation. X plus x bar is equal 1. We can write that as x dot x bar is equal 0. Okay. So here, how to prove this one? So x plus, here x plus in x bar, if x is equal, if we consider x is equal to 1, 1 complement is 0. That is x bar is will become 0. 1 plus 0, we know that is 1. Because plus indicates here OR operator. So if any one of the input is 1, we will get the output as 1. And if x is equal to 0, so 0 plus 1 is equal to 1. So x plus x bar automatically it will become 1. And x dot x bar will become 0. Because suppose here we are taking, if x is equal to 1, 1 dot x complement will become 0. So dot means AND operator. If any one of the input is 0, output will goes to 0. And x is equal to 0, then 0 dot 1 is equal to 0. Okay. So we are, hence we are proving that we are taking two conditions, x is equal 1 and x is equal 0. We are applying to the equation, then we are satisfying that x dot x bar is equal 0. And commutative law here, x plus y is equal y plus x. We know this one, x plus y is equal y plus. So suppose x is equal to 1 and y is equal 0. Same we are getting, for both equations we are going to get 1. Okay. Otherwise x is equal 0, y is equal to 1, 1 plus 0. Same we are going to get, that is 1. So x plus y is equal y plus x. And the duality, how we can write for duality of this equation? Variables will not change, only logical operator x will become AND operator x dot y and y dot x. So this is duality of the x plus y is equal y plus x is xy is equal yx. Associative laws. So here we are taking three variables, x, y and z variables. Three variables we are taking as input and we are adding first two elements. Then the summation will be added to the z. So this is equal to the x plus y plus z. So first we are adding y plus z. Then that is adding to the variable x. Okay. So this is associative law. So for example 1 plus 0 plus 1 we have to add. So first I am adding x plus y. 1 plus 0 is 1. 1 plus 1 is equal 1. Final total answer we are going to get 1. So this is equal to 1 plus 0 plus 1. So first I am adding y and z variables. The summation will be added to the x variable. So the duality of this equation is x, y, z. X, y, first the product of x, y will be happen. Then this will be ANDed by z value. That is equal to the first y and z will be ANDed and then it will be AND with the x operation. So both are equal to the x, y, z. And distributive laws. So here in distributive laws, here we are taking three variables x, y, z and here we have both operators. AND operation we are doing here OR operation. So x dot, here we are performing AND operation. For y plus z we are performing OR operation. So here x dot y plus z is equal. So first we are adding y plus z and it is multiplied with the x. So this is equal to the individual products and we are adding with the xy plus xz. So here xy and xz both and then it is odd. Okay. Duality, how we can write this? So if we want to write the duality for this distributive law, see here x into y plus z. So x here it is dot. Okay. So dot will become plus. So and will become OR operation. And here y and z are performing binary OR operation. So here we have to perform binary AND operation. So that's why here we are writing x plus y into z. So here both here x and y are multiplying. So here it is AND operation. Here we are performing OR operation. Then we are performing and between x plus y and x plus z. So this is distributive law. Simplification theorems. See here in simplification theorems, xy plus xy bar is equal to x. These theorems will be used in the Boolean equation simplification. These equations will be used in the Boolean equation simplification. Okay. So here xy plus xy bar. So here one variable, both we are taking x and y variable. In this equation, x is common, but in the first product here we have y variable. In second product we have y bar. Then directly we can write this. We are going to get output is x. So x y plus x y bar is equal to x. How if x is equal to 0, x is equal to 1 and y is equal to 0. I am taking here. So I should get 1 by using this formula. See here 1 into y is 0 plus 1 into y bar is 1. So 1 0 plus 1 that is 1. So I am getting x value. That is here we are getting x value. So xy plus xy bar is equal to x and x plus xy is equal to x. So here see we are adding with the xy product with the x. So here both the common terms are here x and the second product in second term we have y. So x plus xy is equal to x and x plus y bar into y is equal to xy. X plus y bar into y is equal to x into y. So duality, how we will write this one duality? X plus xy bar is equal to x. So we have to write duality for this one. So x and y are here. We are performing AND operation. So these will be performed in the duality R. Okay. So here we have plus. So here we will get and x plus y bar is equal to x. So this is the duality of this equation. X plus y into x plus y bar is equal to x. In here x into x plus y is equal to x. Xy bar plus y into is equal to x plus y. So x plus y. Okay. Here x into x plus y is equal to x and x plus xy is equal to also x. So these are the simplification theorems. De Morgan's law. Okay. Here De Morgan's law is, we will see the problems of De Morgan's law also in the next slides. We are taking n variables, x, y, z up to n variables. Okay. The sum of the n variables complement is equal to the product of the each individual complements of the variables. So here x plus y plus z plus up to n variables whole complement is equal to the product of the each complement of the each variable. So x bar into y bar into z bar into up to suppose n bar. Okay. So suppose I have three variables, two variables. I am considering here only two variables a and b. So complement of of this AB bar is equal to the A bar plus B bar, and another one is A plus B. The summation of the two variables complement is equal to the individual complement of variables product. Okay. So the duality of De Morgan's law is here x, y, z. The product of the variables complement is equal to the individual complement of the variables, the summation of individual complement of the variables. Okay. So this one. Suppose if you want to write A, B, C whole bar is equal to the A bar plus B bar individual complements, and we have to add those complements. Okay. Here A plus B plus C. I am taking three variables. I am adding these three variables. I am taking the complement of these three variables is equal to the, first we have to write the complement of the individual variable. Here we are performing the OR operations. Here we have to perform the AND operation. Okay, A plus B plus C whole bar is equal to A bar dot B bar dot C bar. And duality means here in De Morgan's law, already we discussed, in the duality we have, normally we have in the equation variables, logical values, that is logic 1 and logic 0, and binary operators plus or dot or complementing. Okay, plus or dot. So in De Morgan's law, what we will do means, we in the duality, okay, we will change the variable. We will take the variable complement. Here we have x means here we have to take x bar. Okay, and logical operator. If we have plus means in duality we will get the AND operator, and if we have 1 means we will get the 0 logic value in the duality. Suppose for example x plus 1 is equal 0. Okay. In the duality what we will take only, we will not change variable. We will not take the complement of the variable. So we will not change the variable. Only binary plus will become AND, logic 1 will become 0, here 0 will become 1. This is duality. Here we will not change the variable name. But in the De Morgan's law, what we will take? We will take the complement of the x. So here we have x means in the duality we will get the x bar. See here x bar dot y bar dot z bar, duality we will get the x bar plus y bar plus z bar. Okay. So here in the duality x plus y plus z whole bar is equal to x by z. So theorems for multiplying out and factorizing. So here we are taking three variables x, y and z. If we write these variables as x plus y into x bar plus z, then that is equal to the xz one term and x bar y. Normally if we write that one xy plus x bar plus z, we will get that as x bar plus xz plus yx bar plus yz. Okay, x bar will become 0. Okay, and we will have the terms xz plus x bar y plus yz. So here this equation by using constants in the equation, but directly we can write this as x. Here we have xy, xz plus yz x bar bar. By using this theorem here, directly we can write xz plus x bar y. So the duality is x plus y become xy plus x bar z is equal to x plus z into x bar plus y. And constants theorem is x plus yz plus x bar. So here if we take xy and this term is same here, and we have third variable here and complement of the first variable and third variable. Okay, then that is equal to the only these two terms will be present. These we can eliminate. Xy plus x bar z. The duality is x plus y into y plus z into x bar plus z is equal to x plus y into x bar plus z. Laws and theorems of Boolean algebra listed in dual pairs. So here if they want to prove these equations, first we have to write the equations and take the truth tables of that one and apply the logical OR and OR operations and finally find out the value. So here identity elements are x plus 0 is equal to x, x dot 1 is equal to x. We should prove this one. So here we are taking two variables x and y. So how many combinations we can get here? 2 power 2. Okay, if we have 3 variables x, y, z, 2 cube, 8 combinations will get. So 4 combinations 0, 0, 0, 1, 1, 0, 1, 1. If we have taking 3 variables, we will get 8 combinations 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay, so here we are taking 2 variables x and y. To prove with the truth table, first I take x and y and write down the 4 combinations. Here x plus 0. First we have to find out x plus 0. So x plus 0 is binary OR operator. So if any one of the input is 1, then automatically output will become 1. So 0 plus 0, 0. 0 plus 0, 0. 1 plus 0, so 1 input is 1, so output will become 1. Here 1 plus 0, 1, 1. So x plus y, so add these two here, 0 plus 0, 0. This is just OR gate operation, binary OR gate. So 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 1. So y plus x, so both we are getting same. So x plus y is equal y plus x, both these values we are getting same. Okay. So x bar we have to find and x plus x bar. X bar means complement of x value. 0 will become 1, 0 will become 1, 1 is 0, 1 will become 0. X plus x bar. So add operation between these two. Okay, x plus x bar. So by writing this truth table, we can observe this x plus 0 is equal whatever x values we are getting, same x values here, x plus 0 we are getting. So x plus 0 is x. X dot 1 is equal to x, x plus y and y plus x, both we are getting same values, and x plus x bar we always it is 1. Okay, and x into x bar is equal to 0. Okay, so this is whatever first A will become these OR operations, dot indicates AND operations. So x dot x bar all zeros and x dot y is equal to y dot x, both are getting same value. X dot 1 is equal whatever x is there, we are getting same value. Okay. So associative law. So x plus y plus z is equal to x plus y plus z. So first we are taking, suppose here a plus b plus c is equal to a plus b plus c. We have to prove this one. So first a plus b we are giving to the one OR gate. So here we are getting some a plus b is equal some x. So this x plus c is nothing but we are giving to the one OR operator. So is equal to the, directly we can write a plus b plus c. So directly we are a 3 input OR gate. Otherwise we can draw this as B, C, A. So B plus C we are adding one time. So that is why we are getting that is added to the A. All are equal to the A plus B plus C. Same for the AND gate also. Write down the truth table. Find out the values. So each term x plus y plus z, and x dot y dot z. Then finally find out the x plus y plus z and by x plus y plus z and x dot y, and again we are getting x dot y here and do the AND operation with the z. So first we have to know the AND OR operations. So for AND operations, A, B, suppose y 0 0 0 0 0 0 1 1 0 1 0 1 0 0 1 1 1. So if any one of the input is 0, for AND operation we are going to get the 0. For OR operations, 0 0 0 0 1 1 1 0 1 1 1 1. So if any one of the input is 1, then automatically output goes to high, that is 1. So if we know these truth tables only, we can write this truth table and we can analyze these laws and theorems. So distributive law, if we want to prove the distributive law, first write down these equations. X plus y into z is equal x plus y individual sum and we are multiplying this x plus y and x plus z. So the duality of that one is, so x plus will become 0, okay, and will become r. So r will become and will become r. Okay, so this is the duality of the distributive law. So take the individual values of the truth tables. Here we have 3 variables, so we are getting 8 combinations, 2 power 3. 8 combinations we will get. Write down those 8 combinations and write down the x plus y and x plus z. Okay, and these x plus y and with the x plus z. So here we have to perform AND operation between these two. So any one of the input is 0, we will get the 0. So here all are 1, so we are getting 1s. Okay, and by here to prove this should be equal to the total this one. So first we perform y and z, and these is odd with the x. So this will be odd with the x values. So OR operation, if any one of the input is 1, automatically output is 1, otherwise it is 0. So these both we are getting same values. So hence it is proved that x plus y into z is equal to x plus y dot x plus z. So like that we have to prove for duality of that equation also. Distributive laws, x plus y plus z is equal x plus y into xz, and x plus yz is equal x plus y into x plus z. Okay, proof for this one is, so we have to multiply these two equations. We will get 4 literals here. Okay, product terms. So we know x dot x is equal to x, we know. Okay, xz plus xy plus yz. So keep these terms here like that only. So here x is common in these 3 product terms. So take out x, we can write x into 1 plus z plus y plus yz. So here 1 plus x is equal 1. So 1 plus this term will become 1. So x dot 1 is equal plus yz. We can write that as x plus yz. So r-ing 1 with any value will become 1. So we are take this term as 1. So 1 plus, take this as a 1 plus a is equal to 1 only. So r-ing 1 with z or y is equal to 1. So write down this total value as 1 and this will become x plus y z. So these idempotency and null elements and involution, also write down the truth table and find out the each R and AND operations and find out the truth table whether we are getting these two values are equal or not. Observe. Okay. X plus y is equal to x, we are getting x dot x is also we are getting x, and x plus 1 we are getting 1, all ones. X dot 0 we are getting all zeros, and x bar whole bar is equal same x value we are getting. Okay, by observing truth table the theorems will be proved. So observation also, so take the x dot y and x y z and another term, add these r with r operation, perform r operation between these two terms. R operation nothing but if any one of the input is 1, automatically the output goes to high, that is logic 1. And to prove the x with the x y plus xz, so take perform xz operation, and we have already xy operation. So these two will be performed between the r operation. So if both these two are equal, so 0, 0, 1, so both these are equal. So this xy plus xy bar z is equal xy plus xz. So like that we have to prove the duality also. In duality, x plus y dot x plus y bar z is equal to the x plus y dot x plus z. So both the values are becoming equal. So here the proof for all the Boolean algebra theorems here, xy plus xy bar is equal to x. So take the common term here x. So that is y plus y bar. So we can write y plus y bar is equal 1. So we are getting that is x dot 1 is equal to x. Okay. And x plus xy, take x common, we are going to get 1 plus y. 1 plus 1 any term variable are with the 1, any variable, then automatically it will be 1. So 1 plus y is equal to 1. So x into 1 is x. X plus y bar by is equal to xy. So y into y bar automatically we know that is 0. So the first term is xy, that we are going to get in the output. X plus y into x plus y bar is equal to, multiply this term, 4 product terms we will get here. Take the common term x, so x into x, this is x, xy bar, yx bar, y into y bar, that is 0. So take the common term in these two, x, y plus y bar, that is 1. So here we are going to get x plus x, that is 1. That is x. So x into x plus y is equal to x, multiply x into x and x into y. X into x we know, x into x is x plus xy, common, take the common term x and we will get the 1 plus y. We know any variable made with the 1 is 1. So x into 1 is x. Okay, xy bar plus y is equal to x plus y, xy bar plus y. So here we can write this as y plus x into y bar. Okay, y plus x into y bar, we can write y plus x into y bar. So here y into y bar. So this is y, this is 0, this is xy and xy bar. So take the common term from here x. So y plus y bar is equal to 1. So we are going to get x plus y. So De Morgan's theorem. See, in the De Morgan's theorem, that is nothing but sum of the variables complement. Suppose I am taking n variables. Okay, if we take the complement, so that is equal to the AND operation of the individual complement of the variables. So that is x bar into y bar into z bar up to n bar. Okay, so if we take the two variables here, x plus y bar whole bar is equal x bar dot y bar, x plus y is equal x dot y. So here x dot y whole bar, duality of that equation is x dot y whole bar. So the product of the variables complement is equal to the sum of the complements of the individual variables, x bar plus y bar. Okay, so how to write? So a plus b plus c whole bar we can write as a individual complements, and if we have performing OR operation here, we have to perform the AND operation at the right side. Okay, to prove that one, take the truth table and find out the x plus y and xy. Okay, complement of x bar and y bar. So complement of x bar and y bar. So x if x is 0, x bar will become 1. If x is 1, x bar will become 0. And find out the x plus y complement. So x plus y complement is 0 will become 1, 1 will become 0. And find out the x bar dot y bar. So AND operation between these two. Okay, x bar dot y bar. So if we get the x plus y bar is equal to x bar by y bar, it is satisfying the De Morgan's law. Okay, x dot y whole bar is equal to here the B equation. So that is the x bar plus y bar. So we are getting same x bar dot. So this is De Morgan's law is nothing but here if we are taking n variables, the summation of the n variables complement is equal to the individual complements of the variables product. And the duality is if the product of the variables complement is equal to the summation of the individual complement of the variables. So here we are taking the Boolean expression AB bar plus C and A plus D bar dot C plus BD. So here we plus implicates the OR operation and this dot implicates the AND operation. This is complement is perform the NOT operation. Okay, if we know these three operations, it is easy to perform the Boolean Boolean logic equation simplification is very easy. So here NAND operation and NOR operation. So here Boolean expression synthesis using basic gates and OR, NOT, NAND is nothing but AND inversion, NOR is nothing but OR gate inversion. Okay. So if we want to express any equation using logic gates, so here C plus D. So C and D is given, place is nothing but OR gate. Okay, we are performing OR operation. So OR gate output is given to the AND with the A. So here it is dot. Multiplying is nothing but dot, that is AND operation. So give AND gate here. A and C plus D whole bar we have to perform. So that is complement is nothing but this is NAND gate. This is NOT gate. This is AND. This is OR. So if we have any additions, we have to use OR gate. If we are multiplying, we have to use AND gate. If we have complement, we have to use NOT gate. Okay. Plus B into E, B dot E. So multiplying we are B and E variables. So we have to use AND gate here. We are getting product B and E. These two terms are added here. So we have to use OR gate. So this is Boolean expression using logic gates. We have to write down the truth table for that one. So for example, A dash B means take A and B, two variables means we'll get the 4 combinations and we have to take the individual, if any products terms are there, we have to take the truth table of that one. Otherwise any complement is of the variable, we have to take that variable complement, and A bar we have to find out A bar plus B, then we will get the final truth table output. So here we have A dash plus B into C whole dash. So we have to perform whole complement of this one. So A bar plus B whole C bar complement. Okay. So here to perform the total complement, then we have to use the De Morgan's law. Okay. Here complement of the products is sum of complements of the individual variables, and we have to perform AND operation. So complement of sum is called product of the complement. So here to perform this one, here we are performing total complement. So here C bar is multiplied with this term A bar plus B. So here products of individual whole complements. So here dot will become plus and individual product terms complement we will get. So again here we have a OR operation is there, A bar plus B whole bar. So here plus is there. So write down dot AND operation and complement of the variables A bar whole bar B bar plus C bar whole bar is C. So this is AB bar plus C we can write. So AB bar plus C. Okay. Like that AB bar plus C, D bar whole plus E whole bar means here plus is there. So that's why here we are getting dot and E complement E bar and this total term complement and perform individual complement. So by using De Morgan's law, we have to simplify equation. We will get this equation. Okay. So complement of A bar plus AB bar. Okay. So summation here. This is one product term. This is another product term. We are complementing this A bar B plus AB bar. We can write this as. So here by applying De Morgan's law. So A plus B whole bar is equal A bar dot D bar. So A bar dot D bar whole bar plus will become here OR operation will become AND operation. So A B bar whole bar. So again here to simplify this product term, here the product complement we have to find out, that is A B whole bar is equal to the A bar plus B bar. So this will become A bar whole bar plus B into, this will become A bar individual complements and will become R and B bar whole bar. So here A bar, A complement, whole complement is equal to the A. So A plus B into A bar plus B. So A plus B into A bar. So to simplify this equation, we are going to get A bar B bar plus AB. And if we want to verify this output with the truth table and find out these truth table combinations, 4 combinations, and write down the truth table for each product term and find out the final output. So these are the books for the references, Modern Digital Electronics and Digital Design Principles and Practices by using Flickr and electronicstutorials.com. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.